All right, as we begin chapter 4 here, as I told you, we are going to slow things down just a bit. We are going to combine sections 4.1 and 4.2. We may or may not spend multiple days on this as well, depending on how you all feel about it. So in sections 4.1 and 4.2, we're going to look at plotting points and graphing linear equations on a coordinate plane. So again, just graphing. Again, some of this stuff should be familiar with you. So first of all, when we talk about a coordinate plane, remember the y-axis is vertical, okay? In other words, it's this axis here. That's the y-axis. And then the x-axis is horizontal, left and right. And again, as far as our graph is concerned, that would be this axis here. Make sure you label them x and y. The origin is the point 0, 0. That's where we always start from when graphing. So it's that point right there, right in the middle, where your two axes meet, and your quadrants go counterclockwise. Okay, so we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So as far as we're concerned, when you're in the first quadrant, your x value is positive, your y value is positive. Okay, let me just do this actually. Instead of putting x and y, I'm just going to put positive, positive. Okay, in the second quadrant, your x coordinate's negative, your y coordinate's positive. Third quadrant, negative, negative. Fourth quadrant, your x value is positive, but your y value is negative. So we'll look at a few examples that kind of relate to this idea of quadrants and what have you. Again, pretty sure that's something you're familiar with. So it says, what are the coordinates of each point? Okay, so you look at point A, we got to go 1, 2, 3, 4. And then up 1, 2, 3. So the x coordinate is 4, the y coordinate is 3. Okay, for B, you got to go left. You start at the origin, go left 1, 2, and that's it. So your x coordinate's negative 2, and we don't go up or down at all. To get to point C, I have to start at the origin and go right 1, 2, 3, and then down 1. So right 3 is positive, down 1 is negative. And finally, point D, I got to go left 1, up 1, 2, 3, 4, 5. So left 1, up 5. And so that's just kind of getting you back familiar with how to plot points, x coordinates versus y coordinates. Okay. Now we're going to plot points. Okay, so plot the point A is 0, 3. So 0 and then up 1, 2, 3. So that guy is A. Point B is negative 2, negative 4. So there's B. D is 1, negative 3, so 1, and then down 3, 1, 2, 3. So there's D. And finally, E is negative 4, so left 1, 2, 3, 4, up 2. There's E. Okay? And when it says describe them, okay, for A, you would say on y-axis. Okay? For B, you would just say that's in quadrant number 3. For D, that's in quadrant number 4. And for E, that's in quadrant number 2. So when it says describe the location, that just means tell me what quadrant the point lies in. So when we're talking about functions and graphing points, a discrete function has a graph that consists of isolated points, as shown in the diagram here. And a continuous function has a graph that is unbroken. Okay, it has to do with your domain. Okay, if your domain is restricted, it might be discrete. If your domain is unrestricted, it's probably going to be continuous. As a general rule here, you can tell that a function is continuous. A function is continuous if you do not need to lift your pencil as you draw its graph. So if I graph a continuous function, my pencil never has to come off the paper. Okay, and so that's kind of an easy way to determine whether it's discrete or continuous. So we're going to go ahead and graph a function, and it gives you a domain. It says domain, so that means x values are negative 2, negative 1, 0, 1. I'm going to go ahead and scroll down just a little bit here and put this guy over here. And 2. That's not what I wanted. And so now we're going to go ahead and plug in. So you can do this mentally or actually do it. So y equals 2 times negative 2 minus 1. 2 times negative 2, that's negative 4. Minus 1 tells you that xy, so the y is negative 5, and the x was obviously negative 2. Okay, when you plug in negative 1 for x, you get 2 times negative 1 minus 1. That's negative 2 minus 1, which is negative 3. So negative 1, negative 3. Plug in 0 for x, you get 2 times 0 minus 1. That's 0 minus 1, which is negative 1. So negative 1, negative 1. Plug in 1. 2 times 1 minus 1. That's just 2 minus 1, which is 1. So negative 1 comma positive 1. And finally, when you plug in 2, you get 2 times 2 minus 1. 2 times 2 is 4. Minus 1 is 3. So it's the point negative 1 comma 3. And then you just plot those points. Okay, negative 2, negative 5. So negative 2, negative 5, negative 1, negative 3. I goofed up here. This should have been 0, negative 1. And this should have been 1, positive 1, 1. And this should have been positive 2, 3. My apologies. And since they tell me that this is my domain, I would not connect the dots. So in other words, it would be a discrete graph, and your range would be all of your y values. Remember, range, y values. Okay, so negative 5, negative 3, negative 1, 1, and 3 would be your range here. Okay, this table shows attendance at a school carnival before and after the year 2002. Graph the function, discrete or continuous. Explain. Okay, so when I plot these points, let's see here. It says negative 2 comma 2.6, so negative 2, 2.6, roughly right there. Okay, negative 1 and 2.2, negative 1, 2.2, 0 and 3.1, and then 1 and 3.5. Okay, and so the question is this discrete or continuous? Clearly, I think it's pretty obvious this is discrete. All right, they are 4 separate points and therefore are not continuous. All right, so a linear equation now. We're getting into graphing. A linear equation is an equation whose graph is a straight line. Clearly, linear means line. Okay, so a linear equation has a graph that is a line and is a continuous function. Okay, and this is the standard form of the equation. That should actually be by, not bx. Ax plus by equals c. Okay, the solution of an equation, the ordered pair xy, is a solution if when you substitute them into the equation, it makes a true statement. Okay, and if you were to graph the equation, the point x comma y that you were given would be on the line. All right, so kind of what we were talking about here. Okay, it says which ordered pairs is a solution of 3x minus y equals negative 10. So we got, or equals positive 10. So we got to try all these out. So in other words, you're going to do, we know this is x and y, so we plug them in. 3 times 3 minus 4 equals 10. We're trying to see if that's true. 3 and 3 makes 9 minus 4 equals 10. That is not true. Okay, so that is not on the line. So I plug in 1, negative 7. 3 times 1 minus negative 7 equals 10. That's 3, that's plus plus, so 3 plus 7 equals 10. Check, that's true. So this is a solution. And then finally, I have 3 times negative 1 minus parentheses negative 13 equals 10. So when I simplify this, I get negative 3 plus 13 equals 10. That is also true. And so B and C would both lie on the line. And they're both solutions to this equation. Okay, the graph of an equation in 2 variables is the set of points in a coordinate plane that represents all solutions of the equation. So in other words, if you were to graph a function and you pick any point that's on the graph, when you plug that back into the equation, it should work out and give you a true statement. Okay, graph the equation. So the first thing we're going to do, you could do it a few different ways. The easiest way is to get y by itself. So add 2x to both sides. This is why we spent time last chapter talking about this. So y equals 2x minus 1. Okay, and now choose values that include plus, positive, negative, and 0. I'm going to tell you in general, we're going to go, our table is going to look just like this. Okay, we're going to go -2, -1, 0, 1, and 2. And that's normally going to be your best bet. Okay? So now I plug in 2 for x. I get 2 times -2 minus 1. 2 times -2 is -4, minus 1 is -5. So the xy here would be -2, -5. I'm going to go a little bit quickly here. So 2 times -1 minus 1, that's -2 minus 1. So this is -1 comma -3. Plug in 0, 2 times 0 minus 1, that's 0 minus 1. So we're looking at 0 comma -1. Plug in 1, 2 times 1 minus 1 is 2 minus 1, which is +1, so it's 1 comma 1. And finally, 2 times 2 minus 1 is 4 minus 1, so that's 3, so it's 2 comma 3. Okay, and so I plot these points. Bring this over here. So -2, -5. Whoops. That's actually not far enough. So -2, 1, 2, -5, 1, 2, 3, 4, 5. Comes off the graph a little bit. -1, -3. 0, -1. 1 comma 1. 2 comma 3. Okay? 2 comma 3. And so now since it's a line and they didn't define the domain, we just picked numbers to plug in, then we would actually connect the dots. Okay, so if they give you a domain, then you would not connect the dots. If they don't give you one and you're plugging in your own numbers, connect the dots and make a line. Okay, it says graph the function y equals -1/2 x plus 3 with domain x greater than or equal to 0. So now x can't be less than 0, so you would not plug in negative numbers. Plug in 0, 1, 2, 3, and 4. You don't necessarily have to plug in all of those, but that gives you an idea. Okay, so now when we plug in 0, I get y equals -1/2 times 0 plus 3. That's 0 plus 3, so x would be 3. This is an XY chart, by the way. This is how we're going to kind of create tables and graph. We've already talked about these a little bit. Plug in 1, you get y equals -1/2 times 1 plus 3. That's -1/2 plus 3, which is going to leave you with +2.5. And we'll plug in 2 just for the heck of it, and then we'll go ahead and graph this function. So I have -1/2 times 2 plus 3. -1/2 times 2 is -1, plus 3 is +2. Okay, so I plot the point 0, 3, 1 comma 2.5, and then 2 comma 2. Again, domain is greater than or equal to 0, so that's kind of how my function would look. Okay, connect your dot. Make sure you put an arrow on this side to show that it keeps going in that direction. Notice I don't have an arrow right here, simply because the graph has to stop at 0. Okay, my domain is restricted. Anytime your domain is restricted, your graph is going to continue in one direction and not in the other most of the time. Obviously, it depends on exactly how we restrict the domain. If it seems like this is going on for a little while, it's because it is. This is 2 sections. There's a lot of material here that we're covering. Okay. It says the number of pages a student types is given by p equals 2t, where t is the time spent in hours. The student plans to type for at most 2.5 hours. Graph the function, identify domain and range. Okay, so we're talking about time here. Time can never be negative, so we got to start at 0. Okay, and since it's 2.5 hours, you can do this however you'd like. I would go 0.5, 1, 1.5, and 2. Okay, and then we'd obviously have to have 2.5 on the end here too. Okay, and again, you don't have to plug in all of those numbers, but gives you an idea. So you're going to start at 0 and you're going to end at 2.5. So domain is 0 to 2.5. Okay? This doesn't make any sense. I have my arrows going the wrong way. So x is between 0 and 2.5. Okay? So now I plug in for the range. So p equals 2 times t, 2 times 0. So this is 0, 0. Okay? Plug in 0.5, 2 times 1/2, or 0.5 is 1. So this is 0.5 comma 1. Plug in 1, you get 2 times 1, which is 2. Whoops, there you go. 2 times 1.5 is 3. So this would be 1.5 comma 3. Plug in 2, you're going to get 4. And finally, you plug in 2.5. 2 times 2.5 hours would be 5. So 2.5 comma 5. So you'd start at 0, 0. Then you go to 0.5, 1, 1 to 2, 1.5 up to 3, and then 2 to 4, and 2.5 to 4.5. And so the graph would look exactly like that. Obviously, I missed this top dot here, but that's okay. And it would stop at both endpoints. It would not keep going because you're going at most 2.5 hours. So now the range is the set of all y values. Well, notice this is your lowest y value, which is 0, and this is your highest y value, which is 5. So your range is between 0 and 5. Okay, or from 0 to 5 would be your range for that function. Okay, horizontal and vertical lines, the graph of y equals b. Okay, y equals b is a horizontal line. Okay, so graph y equals -4, you go to y equals -4. Where is that? That's down 1, 2, 3, 4. And then you just draw a line going through that. Horizontal line going through -4. Done. Okay, the graph of x equals some constant is a vertical line. Okay, so if you want to graph x equals 5, you go to where x equals 5. 1, 2, 3, 4. It's off the graph here. 5. And then you would go up and down through that point, and that would be the graph of x equals 5. So y equals a number is horizontal, x equals a number is vertical. Okay, so example 9 here, we're going to look at graphing equations. So we want to graph y equals +3. Doesn't matter what your x is, your y's are all going to be 3. You can plug in whatever you want. Okay, so you go to y equals 3, 1, 2, 3, and you draw a horizontal line through that. In part B, again, it doesn't matter what your y's are, your x's will always be 4. Okay, so if you know that, you can just go right over to x equals 4, 1, 2, 3, 4, draw a vertical line now, since it's x equals, through that, and there's your graph. Okay, so those are nice shortcuts to know. Otherwise, I mean, you can plug in values here, but it's going to come up with the same graph. It's not going to make a difference. All right. Graph the function y equals -x plus 4 with the given domain. So they're restricting your domain to be -2, -1, 0, 1, and 2. So I plug in. Okay, so I plug in -2 here. So I get, let's see here, the opposite of -2 is +2 plus 4 is 6. I don't have the little table here to work out, so I'm doing this mentally. This is our function here. Okay, so I'm just using these things. I'm plugging all of these in. So the opposite of -1 is +1 plus 4 is 5. The opposite of 0 is 0 plus 4 is 4. Opposite of 1 is -1 plus 4 is 3. The opposite of 2 is -2 plus 4 is 2. Plot your points. -2, comma 6. -2, 1, 2, 3, 4, 5, 6. Going off the page there. -1, comma 5. -1, up 1, 2, 3, 4, 5. I should probably erase these other dots because you can't really tell which one's the graph. And then 0, 4, and 1, 3, and 2, 2. Sorry about the graph here. Clearly, I put the wrong one there. But anyway, so is it discrete or continuous? It's continuous. It's discrete because it's just a bunch of points. And they said restricted domain, so I do not connect my dots. My domain is only allowed to be these numbers. That's it. Okay, so hopefully, I'm not going to worry about that second part. Hopefully this video kind of provides you with a good introduction in terms of how to graph lines, how to plot points, quadrants, different things of that nature, so that as we work through some things in class, you can catch on rather quickly and feel pretty confident.